Okay guys, welcome back to our Bonding and Molecular Structure unit. We are in day 5 of C.3.4. Today we are discussing polyatomic ions. Polyatomic ions are needed to know. In the parentheses to the right of these polyatomic ions are natural occurrences when dissolved in water, be it lake, ocean, river, plant life, or blood. So, for instance, the carbonate ion naturally occurs in limestone. The sulfate ion naturally occurs in gypsum board. The nitrate ion naturally occurs in saltpeter. The phosphate ion naturally occurs in bones. And the bicarbonate ion naturally occurs in hydrogen carbonate. Is hydrogen carbonate. Is also known as hydrogen carbonate. So you were going to have access to these polyatomic ions. Remember that these these superscripts are what you're looking at to balance. Although there are 3 oxygens in the carbonate ion, it has an overall -2 charge. So when you're balancing, you're looking at the superscripts. And you're going to flip those around and put those down below, right? So remember how to run your multiplication. This will go to the bottom here, right? So superscripts become subscripts. We have more polyatomic ions that you need to know. For the following polyatomic ions, chlor, Cl can be replaced with iodide, or Br, bromine. So, for instance, these are written out. So we have hypochlorite, chlorite, chlorate, and perchlorate. Same thing over here with the bromine and the iodine. So we have hypobromite, bromite, bromate, perbromate. Then we have hypoiodite, iodite, iodate, and periodate. Notice that the only thing that's changing is the brom, chlor, and iod. So we have hypochlorite, hypobromite, and hypoiodite. These, again, will be available to you at all times. So we have naming polyatomic ionic compounds. We have a cation name plus an anion name. If you know your valences, this is easy. Remember, valences are positive to the left of the staircase and negative to the right of the staircase. We're not looking at stock convention anymore, okay? So we're back to just the regular old metals and nonmetals and metalloids, okay? So there's not going to be any like Roman numerals used here. You're going to be looking at the superscripts, remember? And that's going to tell you what to write for the other one subscript. So the first name is the cation name, and the last name is the anion name. You need to balance each atom or polyatomic ion present. I'm going to pause the video and run through these examples with you. We're going to write the subunit of the compound and the charge on the subunit. Okay, good job, guys. Okay, for naming polyatomic ionic compounds, more than 2 ionic atoms are present. For example, for zinc sulfate, zinc ion is Zn plus 2, right? And the sulfate ion is SO4 2 negative, okay? So, because there's a 2 and a 2, that means that we're not going to have any additional things at the bottom, right? Right. Since plus 2 and -2 cancel each other out, we simply combine the ions as they always are. I know, there's a 4 down here. What's happening? Well, no worries. That 4 is carried over from the original polyatomic ion, okay? Naming polyatomic ionic compounds again. If more than one polyatomic ion is needed, you must put that polyatomic ion inside of a parentheses. 3 ammoniums. So it would be a parenthesis, how many ammoniums, and then you'd have an in parenthesis and a subscript of 3. Does that make sense? So 3 ammoniums are needed below. So we have ammonium is NH4 1 plus, and then we have phosphate is PO4 3 negative. So what that means is we're going to put parentheses around these, right? And then that way you don't confuse the 4 on the hydrogen with the 3. If you put 4, 3 next to each other, that means you would have 43 hydrogens. Well, that's not possible. Okay, not to nitrogen. So not to most things. So yeah. Remember octet rule, we're only trying to get 8 in the outer shell. Okay. So what's happening is we're taking the superscript and we're flipping it around at the subscript. Superscript, flipping it around the subscript. We don't want to write 1 after here, okay? It's automatically a 1 if there are no parentheses, okay? We know that this is a unit. We know that this is a unit, okay? We have NH4, and then we have the in parenthesis 3. This 3 has been taken down to the bottom. The 1 has been taken down to the bottom. We're not writing 41 oxygens here, right? Right. Since 1 and negative 3 do not cancel each other out, we use subscripts to take multiples of an ion. We've done this before, we just haven't done it with using parentheses, okay? Since we are taking more than one of the polyatomic 1, it must be put in the parenthesis first. Alright, I'm going to pause the video and we are going to formulate these words or name them as that we see fit. So these top 4 are going to be formulas and these bottom 4 are going to be names. Alright guys, you did a great job. We are going to go ahead and do the polyatomic compound predictions and the crossword. Thank you so much for being excellent students.